Okay, just one of the most important days of the year. So if you do miss, make sure that you watch what we've done. When I was in college, I took Cal 1 like my freshman year. I didn't take it in high school. But I remember just checking the back of the book, a college teacher, and also I am your college teacher. I probably moved faster than Dr. Staten moved with me, just because we even have less time together, which I've spoken about before. There's a week coming up soon that I only see you one day, and then I don't see you again for another week. But
one day
I'll manage that with videos. Anyway, I remember distinctly thinking, I don't know how to, what I call, clean up these derivatives. Like, I can take the derivative, I can learn anything. I do the product rule and the quotient rule. I don't have anything to phrase hang my hat on. Like, I don't have anything to hold on to go, I'm going to be able to do this every time. And so really, I don't know if you'll see this anywhere in a book, but I came up with my own 3 steps that I've always taught my students that will get you there. So this is a place this is huge, this is big, okay? And so what I found that would work for me, and it'll work for you, is that first you want to take care of your negative exponents. First you want to take care of your negative exponents. Second, you want to find common denominators. And third, you want to factor. It will go against your intuition as a person that has been taught to distribute. Distributing is usually not, I'll do it some today when it's super easy and it makes my life easier. But girls, more often than not, we're not distributing, we're more pulling it apart, and we won't factor. It's going to be real important, like I mentioned in the last class. You may wonder why they care what form you have it in, and they're setting the stage for a couple more sections down the road where you want to see where your derivative is 0 or undefined, because super important things happen when your velocity is 0 or undefined. Maximums, minimums, important events and stuff like that. So, negative exponent, common denominator, factor. Negative exponent, common denominator, factor. I'll say it to you a lot, say it to yourself. There's a lot of times you don't have a negative exponent, so bypass that step and go in order to common denominator. There's sometimes you don't have negative exponents and you don't even have fractions, then go to factor. If none of that applies, you've got something super simple that you're just going to be able to clean up without any direction anyway. Okay? So I have a few that I'm going to talk about, and let me open the book to that page. I'll tell you what, before we go on, let me go ahead and teach you the chain rule. It's like the new rule. There's the power rule that we love, the product rule, and the quotient rule. If I made you do it like the longer way with f of x plus h minus f of x over h with these 2 functions next to each other, it would be a nightmare. So even though we're not really fond of the quotient rule, it's far better than the alternative that people have found these tricks that work. Going to be memorizing your trig derivatives, which I flew over in the last class. So there'll be the power rule, the product rule, the quotient rule, and the chain rule, and your trig derivatives. That's pretty much what you learned in chapter 2, and then we start applying it. Okay, obviously that doesn't cover all the bases, and so I'll teach you how to take derivatives of exponents and logarithms also. Don't panic in the order all of a sudden. There's sometimes that Miss O.D. gets to, because of where it comes up in our book or syllabus, this book waits to do exponents and logarithms till like chapter 5 or something. Doesn't matter when and where I teach it to you, we're definitely moving faster, and we'll even be going faster and faster. Or if you talk to somebody from another school that's already in chapter 7 or something, don't panic, I got you. Okay, so just stay with me, all right? But keep in mind, like Caitlin and I talked about one this morning, that didn't even have equations. It's got a picture, and you'll be required to do that. So you've got to know it numerically, graphically, and algebraically. Okay, be that as it may, let me teach you the last rule in the series of power rule, product rule, quotient rule, chain rule. Those are the 4 things that can happen to you algebraically, okay? So this is the chain rule. And the proof of it, well, what's going to happen is if you have dy over dx and it's some kind of composite function, I'm gonna take the derivative of y with respect to u, and then I'm gonna take the derivative of u with respect to x. What I mean by that is, what if I have y equals 2x plus 1 squared? As of right now, you don't know how to take that derivative unless you do one of two things. Well, what are some ways, if I put that on the test without any more instruction, that you would be able to take that derivative, Carla?
You can make it 2x plus 1 and 2x plus 1, or you can.
Okay, so Carla could do the product rule, or she could FOIL it out and do the power rule. So she has two options. We'll do both. We'll do one of those. Let's FOIL it out. So I would simplify it on the front end, which is a big 4x squared plus 4x plus 1. By the way, girls, you'll be hearing me say a lot. I can guarantee you it's in your best interest to simplify things on the front end whenever you can rather than on the back end. It's going to be a whole lot easier if you make it simpler with your domain in mind. All right, this derivative is really easy then, Carla. So we would get 8x plus 4. Provided that I didn't make a careless mistake. At 0, f prime of 0, we get 4, okay? So we're gonna look at that in just a minute, pull it all together algebraically, numerically, and graphically. There was something I was gonna say. Oh, always give me your notation. I talked to a couple of people that came by this morning about that. Don't just say that 4x squared plus 4x plus 1 equals 8x plus 4. No, it does not, okay? So you know how I'm in the habit of always writing limit of the function as x approaches a. I'm always in the habit, if I've left y, to say y prime. In fact, we'll even go into y double prime, like we were talking about the higher order derivatives. You gotta state for yourself, for the person you're working with, for the grader, what it is that you're talking about, okay? So let's see if this makes sense to us. If I fill in 0, I get 1. If I fill in 1, it shoots me all the way up to 9. If the vertex is at negative 1/2, negative 1/2 gives me 0. And so it's going like this. Can you see that it would make sense for the slope to be 4? Looks like it's pretty steep, and I probably didn't draw it all that well anyway. I can see that unit when I went back one unit. I kind of went too far in the scale of things, so I probably should switch it up some, which would draw it up. It's a pretty steep slope. In fact, 4 is an extremely steep slope. It would be a little bit more vertical than that. Okay, now, what some people try to do is they try to do this. Like, they're like, oh, I'll just do the power rule. Y prime is 2 times 2x plus 1 to the first. Don't ever do that. Okay, first of all, in this one, you happen to come close to what we know is the right answer. We come really close to it, don't we? We would get 4x plus 2. But we would get a completely different slope, so apparently that doesn't work, because we know this one that Carla suggested works. I wanted to do it and go, don't do that. Girls, the derivative of sine of 2x, unfortunately, is not cosine of 2x. Okay? All of a sudden, I'm doing something that you haven't faced. I have a composite function. I use the word blah a lot, okay? Like B-L-A-H, like blah, 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 meaning I don't care what's in there. This is a composite function. This is a u squared. Do y'all see it's a something squared? So there's two things going on in a composite function. They're monumental. Something's being squared and something's being doubled. If you have sine squared x, there's a lot going on in that, isn't there? Sine squared x. You can't just say, oh, that's 2 sine x or 2 cosine x or whatever it is. You can't do what you want to do, let me tell you that. Your temptation is just to bring it down, and it'll be sitting there in your multiple choice, okay? All right, so anyway, you can't just do what you wish you could do. What you can do, I will teach you the chain rule, and there's a reason it's called the chain rule. But somebody remind me in a minute to tell you what to do if you have a triple product. That's a side note. I just splitting around in my head. I need to tell you, if you had something like x cubed times sine x times e to the x, and you had 3 things next to each other instead of 2. I've gone this far, I'm going to tell you. Okay? If you have 3 things that you can't simplify, like x squared sine x and e to the x. And they're just slapped, backtracking the product rule, okay? What you would do, it's been proven that you would hold 2 still and take the derivative of the third, and then they would take turns. So I'll write that down for you now that I've gone that far. So this is a side note. Sorry, I kind of went off topic here. If you have a y is equal to f times g times h, 3 completely different functions, the derivative would be first and second times derivative of the third, first and third times derivative of the second, and which one I haven't done, first, second, and third times derivative of the first. So similar, and that could go on and on and on. You hope you don't encounter that. I don't think you will. But if you do, if you have 4 of them, well, I think you could deduce what you would do. You hold 3 still, take the derivative of the fourth, and do all the interchanging of let everybody have a turn. It pops up occasionally, so there that is. All right, let's go back to the chain rule. Okay, question? Okay, does that make sense, Anna?
Yeah, that makes
Okay.
sense.
So everybody gets a turn, just like in the, if you have 2.
Oh, yeah. Wait, so is this the chain rule?
No, that's why I kept saying, oh, side note, when I said, somebody remind me, I thought I was going to get this out of the way. This is not the chain rule. This is what's called the, it's still the product rule. It's just what do you do if you have 3 or more things multiplied together and you just practiced with 2 and almost always will have just 2. Okay? All right, so you can actually see, while I'm off on the side note, while I'm off the topic, why technology is so vitally important. People do look at derivatives, but a lot of times they're looking at it with their technology, but if they don't know the calculus without the technology, it's not going to be good. But anyway, let's go back to the chain rule. All right, so let me go to this slide. In fact, I'll just erase this and use this slide. Okay, so let's say if I have f of g of x. All right, does everybody understand that's a composite function? You're intuitive enough to know that there must be something that helps you deal with the inside and the outside. If I have sine squared x, there's a couple of things going on. If I have 2x plus 1 quantity squared, there's something going on. There's something in the inside that's doing a vertical stretch, and then on the outside it's squared. And I gotta compensate, I gotta figure out both of those things. Oh, by the way, what if I had started off with this one? Or this one? I obviously started out with squared because of what I knew that somebody would say, like Carla did. I could just square it out or put it next to each other. Here, I don't want to do a quadruple product rule, nor do I really want to multiply it out, because even though I'm good at it, I'm probably going to mess it up. Okay? Do y'all see that? I don't want to do that. I'd rather please teach me the chain rule. Do y'all see that one I can't even get to? And you would know there's a vast difference in the square root of x plus 1 and the square root of 2x plus 1. The graph looks completely different and has different slopes. Okay? So, whenever and I'm going to get there, whenever I taught you the derivatives of sine and cosine, I usually even write them this way. I was just flying at the end. But I usually give it to my students like this. The derivative of sine of blah, sine of u, it's not always going to be x. What you really do is the chain rule, and I'll write it down. So the root of the derivative of sine u is cosine u, but doesn't matter what u is, because that could change your graph. Okay? So I think I'll go in and fly through a proof of it and hope I get it right. So what do you do if you have a function inside of another function and you can't like easily fix it? Let me tell you, if I could easily fix it, even though I know the chain rule, I would do what Carla suggested. And if I have just something that's squared, I would just multiply it out and do power rule. Other than that, I would want the chain rule. But both of them should work. All right, so the limit formula is f of g of x plus h minus f of, take the limit I probably shouldn't scoot over, as h approaches 0. Alright, so we're supposed to do f of x plus h. So I have f of g of x plus h minus f of g of x over what? Okay, so over x plus h minus h, so over h. Alright, and then you can't really get anywhere with that, like you're still stuck, okay? And you're going to insert something like I did the other day, so you get more used to what you're going to insert. So I'm going to have f of g of x plus h minus, and I always forget what I'm going to insert in both of these. Oh, that's why I stumbled over. Did y'all see I went over h? Because it's not normally how I do it. There is a way probably to do it with the formal definition of a limit, but it's a little easier, and our book does it with the alternate form, which is good to look at anyway. So I may do this one for you next time after I think about it a little while. We could introduce something in here that would get us the chain rule, but I'm going to do this proof that I looked at earlier with the alternate form. I knew that wasn't feeling what I was going to do. Sorry. All right, so let's do the alternate form. So I have the limit of f of g of x minus f of g of c over x minus c as x approaches c. Do y'all remember that alternate form? It could be a or c or whatever. Okay. So now I'm going to introduce something else in here. And if I think it's one where I add and subtract to where it's sort of a wash. So I'm going to put in, oh no, I'm going to multiply. Okay, so I have f of g of x, or I could just do it right here. All right, I'm going to multiply by g of x minus g of c over g of x minus g of c. And that is a legal move. I can do that because I've multiplied the top and the bottom by the same thing. Now I'm going to regroup it. I'm going to write this as the limit as x approaches c of f of g of x minus f of g of c. I'm going to slide this over here, g of x minus g of c. And I'm going to put this, I'm just going to switch these two, which I can do because it's multiplied on the bottom. And this is g of x minus g of c over x minus c. Now we've got these very permissive limits that we don't have the luxury of probably ever again. Well, it'll come up with sigma also. But I can just do this limit and that limit as x approaches c. What is this? How would I write that? If somebody's gone g of x minus g of c over x minus c, they just took the what of g? So that's g prime of x. And if this is f of u minus f of z, isn't this over u minus z?
Yeah.
Anybody translate what that would be the derivative of? Okay, this one was g prime of x, right?
Yeah.
Because it had x minus c on the bottom. So this must be f prime of whatever's in there, g of x. So this is f prime of g of x. And that is your derivative. This is your chain rule. I'll show you why it's called a chain. It's because it just continues on and on and on sometimes. Most of your chains are just going to have two links in them, okay? Now let me tell you what that says, and I'll do some for you, and then we'll just start back on going over homework. And we'll continue to do that this week. Anyway, this says take the derivative of the outside and leave the inside alone, but then go back for it. So take the derivative of the outside. You've got to discipline yourself. I can promise you, you're going to trip up and do too much too soon. You take the derivative of the outside, leave the inside function alone, but you better go back for it because it's also impacting the graph. Okay, called the chain rule. It's for composite functions, f of g of x. Okay? So you take the derivative of the outside, leaving the inside alone and go back for the inside. There'll be all sorts of temptations here. A couple of temptations is to never go back for the inside and just bring your power or whatever down. The other temptation is to do it all together at once, like the derivative of the outside and the inside. Don't do that. That won't work. You can see the proof. Now there's the proof. I'm going to go back to the slide that I had earlier, if I can. Let's go back to this one. What if I use the chain rule? What the chain rule tells me, do y'all see a u squared right now? This is a blah squared. I don't care if it's sine squared or 2x plus 1 squared or ln x squared. There's something being squared, and that the composite function, that is the squared is the outside. It's the overriding thing. It's the last thing that was done to it, and it has a big impact. So I think of that as a blah squared. So when I take the derivative using the chain rule, I just pretend like that's just, I don't care what it is, it's just u squared. So first I'm going to say 2u to the first. Do you see how I brought the derivative of the outside? I brought my 2 down using the power rule, and I've got this composite inside, and subtract 1. But now I've got to go back and multiply it times the derivative of the inside, which is what? 2. The derivative of the inside is 2. And so I get y prime is 4 times 2x plus 1. Do I get the same derivative?
Yes.
Now doing it with just one problem's not a proof, that's why I stopped and did a proof for you, but it's pretty convincing, right? That it's going to work. All right, so let's go back to this statement again now that I've talked about it so much, because that probably didn't make any sense to you at first. But you take the derivative of y with respect to what's on the inside, and then go back to your derivative of u with respect to x. I'll do it for you right now. I was going to say in a minute, but it might be good to do it for you right now. Y'all, hopefully you agree that 2x plus 1 is u squared if u is 2x plus 1. There's no need to write it like that, even though some of your homework may get you to pull apart composites just to get used to composite functions, to get you really grounded. But anyway, is everybody okay with that statement? So if I take the derivative of this, my danger is just to call that 2u to the first. In your experience already in pre-cal, u is usually a whole entire other function that you're just pulling out for a minute for a quick fix, okay? So now I can't just leave that alone. According to the chain rule, I then have to go back and take the derivative of u, which I can write as du or u prime or whatever, okay? Notation we're gonna really hit hard in the next couple of weeks too. U prime can mean du over dx, your variables make a big difference. You could have dv dt. There's all sorts of things that rate of change means. When I say, in fact, y'all have seen dy over dx, I guess, have you? Y prime is dy over dx. Let's pause for a minute, just for a second on that topic. Like I said, it's a huge important day. What does this mean? Now, I had never had physics when I took calculus, and so I knew my physics friends were a little more well-versed in it than I was, but in a way I kind of had an edge because I was looking at it as a pure math student. That just means the difference quotient is what we call that. Do y'all see that's y minus y over x minus x?
Yeah.
What does dy mean? Doesn't that just mean y2 minus y1, the change in y over the change in x? In physics, I think you use the capital delta more, and when I get into differentials, I'll tell you why I don't use that Greek delta very much. I usually use the little one, but I'll explain that later. It doesn't matter if you use delta y over delta x or dy over dx, okay? Technically, delta y over delta x is going all the way back to geometry and really finding 2 points difference, whereas dy over dx is an approximation, but it's an incredibly good approximation because how close am I getting my 2 points? Infinitely close. Okay? All right, so anyway, do y'all understand this just means the difference quotient? It can be written like this. It can even be written like this. The derivative of y with respect to x. Right now, I think all you've seen mostly is dy over dx's, but you got some homework with t's. That would be a dy dt. You're taking the derivative with respect to time. I've even seen dx dy. It's unusual, but that means now all of a sudden I care about more x than I do y. Okay? There'll be all sorts of things especially in parametric mode, and polar mode. So those are notations. I can't think of another notation that you'll see. Let me go on and talk about the second derivative, because you might see it before I think to tell you. And I usually use that notation because I hate this one. In fact, I usually forget where to even put the little twos. I think it's on the outside and the inside. That means second derivative. The reason they don't write it like this, you may think, why don't they just do that? But doesn't that mean you've squared the derivative and you haven't taken the next derivative? So if you see one of the twos shifted over into the middle of the two numbers, that means you're not talking about something squared, you're talking about the second derivative. I promise you'll get used to it, okay? So, let's go back to this slide. All of those mean the first derivative, by the way. Back to this slide where I was. Okay. So let's finish this up and then I'll land over there. So I have y prime. All right, so what did I do here? Because I'm kind of talking all over the place. I went 2 blah to the first, then I went back in for the derivative of blah, or the derivative of u, whatever's in there, okay? Now that was 2u, which is 2x plus 1, and what was u prime? Isn't it 2? And isn't that what I got up here? In fact, you can see it's exactly what I got right here. So that little short thing I wrote that you maybe didn't understand, I really like it better than that long proof I just kind of actually stumbled through. I think it makes more sense to people. If you have a dy over dx, and that happens to be a composite function, you take the derivative of y with respect to just subbing in u first. Like if I have y is equal to sine 2x. What's the overriding thing here? Which function? What's the most important? Sine, the outside function, is the most important, but will that too also impact the slopes of the graph? We'll talk about how it will in just a minute. But do y'all see how I'm talking about this? First of all, is that what your eyes even see? Sine of blah? No matter what's back there, you think, oh, it's the sine of something. It's a composite function with the sine. So what I'm going to do is I'm going to take dy dx by saying the derivative of y with respect to u, and then I'm going to take the derivative of u with respect to x. So let's do that. dy over dx. What's the derivative of sine u? You are getting used to it, is cosine u. But we know we've got to account for what u is doing, which is 2x, and what's the derivative of 2x? 2. So my derivative is 2 cosine u, but what was u during this time? 2x. This is a great proof of the chain rule, though. So you've got to remember that, y'all see these cancel out? And it does find you the derivative. You take the derivative of y, take the derivative of the outside, then go back to the inside. Hopefully you see that's what that's saying. Okay? The good thing is you don't have to prove it to me. You just have to do it. I want to go to this. And I want you to tell me before I tell you. How does this make sense? Gosh, and I think you certainly know this by now. I just love mathematics, and I love the fact that we can talk about how it really manages what's happening in the real world. When I take this derivative, you won't be tempted to say the derivative of that's cosine 2x. Huge temptation. Okay, but you see a composite function. So you can never again just jump in and take a derivative. You have to pause and go, do I have a composite function? Okay, and then, you know what? It's not going to hurt anything to treat every derivative like this. Watch this. The derivative of sine of blah, the derivative of sine of x is cosine x, and then what's the derivative of x? 1. It's not going to hurt me to go back in. Do y'all see what I mean? You just always do the chain rule until you get good at it. All right, back to this. The derivative of sine of anything is cosine of that statement times the derivative of that statement, which is 2. Once again, the chain rule. I'm taking the derivative of the outside, leaving the inside alone, and then I go back for the inside. Who can tell me why that makes sense? What is it doing to my slopes?
Increasing.
it's increasing my slopes, Carla, isn't it? Why does that make sense? What is sine 2x different from sine
The amplitude
x?
is.
Yeah, okay, but it's not amplitude, what's it changing?
The period.
The period is changing the amplitude of the other one.
Yeah.
Does that make sense? Why does that make sense? A sine graph looks like this. Lazy sine graph out to 2 pi. But this one's going to be finished by the time it gets to what? What's the period of sine 2x is pi. So it's like a lazy sine graph that somebody did this to. What's it going to do to all those lazy up one, down one?
Smush them.
It's going to squish them and make them more steep, isn't it? So I thought the slope here, I'm drawing these really horribly, but y'all know from experience, if I graphed it better, that looks like negative 1, 2, okay? But now all of a sudden, what does it look like the slope is? It looks like negative 2. Do you see all of those slopes get steeper? And if I really took some time with it, you would actually realize that you would have to plot that as 2 cosine 2x. All right, so let me do a couple more, and then hopefully we'll come back to that even more. And I'm just going to kind of be careful with the homework because I know I really beat you over the head with it for today, which I'm going to do sometimes because you signed up for this class. All right, so what if I have y is equal to sine cubed 2x? You can get lost in these, and I want you to always be found. So I always start with the outside, leave the inside alone, but now you're going to see what's called the chain rule. This one's going to have 3 links in it. There's 3 functions here. What's the overriding function? Couldn't I rewrite this as sine of 2x cubed? Y'all see that? It's blah cubed. And I don't care what's in there. All right, so I'm going to take the derivative. I don't care what's in here, girls. You're just going to have to hold that still. So you're thinking of that as u cubed. So I'm going to have 3u to the second, and I'm going to leave the inside alone. So I'm not really canceling it out, but I'm making a note to myself. I took care of that one. Okay, it's not really calculus terminology. So I took care of the 3, leaving the sine 2x alone. Now who do I take care of next? Good. Leaving the 2x alone. Do you see how much discipline it's going to take? Okay. So now take the derivative of sine, and when something's not check marked, you got to leave it alone. So next to that is the chain 2x. Until finally I've got to take the derivative of 2x, which is what? 2. And I probably would go in to make that a 6 out here. Okay, but for our sake right now, I'm going to do that. So do you see how this is a chain with a link? It could just go on. I mean, somebody could be really mean and you just got a chain. I can't draw, but those are links in the chain. Okay? That's why it's called the chain rule. And then I would call that 6 sine squared x, and no telling what I would have in the back of the book with identities and stuff. Okay, so now let's go back to homework. There were a couple of hands up. Are there any questions about just the intro to chain rule? Yeah, what I just taught. I think you had your hand up earlier.
Oh, I just wanted to see one with like a square root. Those are so hard.
Oh, I'll do one with the chain rule, then we'll go back to homework. Okay? So, with the chain rule, because right now you haven't had to do that. If you look at all of your square roots so far, it was square root of x. And so you didn't have anything inside. So if I'll pull one out of the examples. And that's a big part of what we're doing today. Okay, here we go. You ready? We're going to do product and chain rule. So we're putting it all together. Okay, sometimes you will have a product rule inside your chain rule. Sometimes you'll have a chain rule inside your product rule. Don't sweat over it, just see what you've got. Like sometimes say it out loud to yourself for the test, at least mentally. Like, listen to me say that, x squared times the square root of 1 minus x squared. Do you see, I have a product rule, I have an f of x times a g of x. But when I get to g of x, what rule will I encounter as I'm trying to make my way? The chain with the square root in it, okay? So this is even going to be worse than last night's homework, so I didn't pick some piddly thing. It would be horrible to simplify, I thought, and until I finally, in desperation, came up with something that's gonna work for me and for you. All right, so product rule. First times derivative of the second plus the second times derivative of the first. I discipline myself to write all of that out, and please do. Please follow my lead. I'm your biggest cheerleader, okay? So, I've got your best interest at heart. If you don't do that all the way out right now, chances are you'll get caught up in the chain rule and forget the second part of your product rule. So first times derivative of the second plus second times derivative of the first. Now when I say first, and what's the derivative of the second is the square root of blah, square root of u. So I'm going to bring down the 1/2 times blah to the negative 1/2, okay? Am I finished with the derivative of that? I got to go back to the inside and take the derivative of u. So this is the square root of u. 1/2 u to the negative 1/2. Now I'm going to say the derivative of u, which some of you know is what? What's the derivative of the inside? Negative 2x. All right, did y'all see that chain rule? You're brand new to it. So I said 1/2 blah, you can just cover that up with your hand. 1/2 blah to the negative 1/2. Now I've got to deal with that, which was negative 2x. So first times derivative of the second, then I have plus the second times derivative of the first. Right now, a lot of us probably thinking, I wish I hadn't asked that because this looks worse than last night's homework or just as bad as some of the hard ones. But now your life is going to be easier, okay? Negative exponents common denominator factor. Negative exponents common denominator, that little scary underlook's landing on me. Negative exponent common denominator factor. If you see a little canceling, do it. Be very careful because that's my calculus. Where am I going to make my mistake most likely is in my algebraic steps, okay? So be careful, and y'all watch me because you know I make lots of mistakes, especially when it's way up high on the board. Negative exponents common denominator factor. Let me finish, don't forget your question. Unless I made a mistake.
Isn't it negative 2x, not just 2x?
No, this is second times derivative of the first. Derivative of 2x of x squared is
sorry.
Okay. But always do that what Grace did. Like if I say, don't ask your question right now, but I made a mistake. If he's ever brought that, go, you made a mistake. Okay. Raise your other hand so that I don't want to go forward if I made a mistake. All right, so now I think I'll cancel out those 2's. I'm not going to cancel out a whole lot. I'm not going to stress over it. But these 2's are gone, but I got to keep up with everything. That's a negative x in my really bad handwriting. Negative exponents only bump down to what they're directly attached to, okay? So this is x squared times negative x on the top is negative x cubed over the square root of 1 minus x squared. This one is just 2x times the square root of 1 minus x squared. It's amazing how these clean up. That's a Miss Lazari phrase. I don't know anybody who says clean them up. You're probably not going to find that in the back of the book based on your homework experience, where I know so many of y'all so well, and I'm getting to know the other ones, and I'm sure you're all the same, but you're working really hard on this. If you're not, you'll be sorry in a hurry. You got to really, really work hard, okay? Negative exponent, what was next? Do you remember in my list? Common denominator. So I'm going to get a common denominator. So I'm going to multiply this by the square root of 1 minus x squared over the square root of 1 minus x squared. Okay? So it gives me negative x cubed plus 2x times what? What's that times that? 1 minus x squared over this denominator. By the way, notice some things before I finish. This one has some limits on its domain. I can't use something like 2 or 3 or 4 because I'll get a negative under the square root. In fact, this whole thing only exists from negative 1 to 1 inclusive. I could put in 1, want to make the whole thing 0. But you see how I'm real aware of the domain? The graph probably looks crazy, but I'm really aware of the domain. It's right now only negative 1 to 1 inclusive. But is the derivative inclusive of negative 1 to 1? All of a sudden, negative 1 to 1 are not allowed in your derivative, whereas they were in your original. I'll just make that point and leave it there until we get to something more important. All right, now, if I do this right, don't ever get in a hurry. Take your time when it's your grade, but I think I get negative 3x cubed plus 2x over the square root of 1 minus x squared. So it looks pretty nice. The aggravating answers in the back of the book. Let me make sure I got that right. Okay, and then what's your third step? Negative exponent, common denominator factor, negative exponent, common denominator factor in that order. I can factor out an x, but will it do any good right now? But if it would cancel out, I want to factor it out, so it's super simplified. Later on, it's going to be real important for us to look at what makes it 0 and undefined. And super important things happen to our function at those places. All right, so now, Alana, now that I've just done that one, let's go back to some more, and I have a few picked out. So that was a good intense chain rule there. Chain rule combined with the product rule. Okay, so now I'm just going to hit homeworks. Please get in the habit of doing this for me. And for you, not for me, but more for you. That's what I'm all the time. All the time. Girls, when you're doing your homework and you have lots of questions, most of you are organized enough to put a star by them or mark them or something. The ones that I don't get to, you might want to, or the ones I do, cross them out as I go, or highlight the ones I didn't get to. Find your own system, because before a test, sometimes in class I'll say, okay, review, what questions do you still have? But if I don't do that, it's also better for you on a daily or I see some of y'all every day, sometimes a few times a day in the math center, but you could come in and ask me 2 questions and keep on going, okay? So please somehow keep a record of what I have not entered for you, because it'll be individual to you. All right, so let's go to, I'm gonna start with number 1. Number 1 on last night's homework. We're now on last night's homework. Number 1. What'd you say, Morgan?
Nothing. I was just gonna read it out to you so you didn't.
Oh, okay. But that would be great, because I could stand here and do it.
X squared plus 3. This is parentheses. And then parentheses x squared minus 4x.
Okay. The only reason I wanted to bring this one up, I might not actually work it, you probably got this one right, okay? But this one goes back to Carla's 2 alternatives. You can FOIL it out or do the product rule. I don't care. I probably wouldn't do the product rule here. I probably would FOIL it out and then take the derivative. Are y'all okay if I move on from number 1? I just wanted to make that point. Okay, did you write all of them down, Morgan, the question, so I can just write instead of the book? All right, I'm jumping to number 9. So this is number 9, but wait. Number 9, okay? What's number 9?
The square root of x over x cubed plus 1.
Okay. Girls, notice that I don't have any composite functions in here. Now I could give you the square root of 7x minus 4 over x cubed plus 1. And you would have a quotient rule with a chain rule inside. Let me write that down. Don't write this down. Please just look. Because we're not going to work this problem. But I want to compare the 2 and just let you know you're going to be okay. Because you may wonder what I'm saying. Sometimes you have a chain rule inside of a quotient rule. Sometimes you have a quotient rule inside of a chain rule. And how will you know when you got that? Okay? Don't I have an f of x over g of x here? So that's a quotient rule. I'll go low when I hit d high. I've got a chain rule that I've encountered. Do y'all see that?
Yeah.
Here, that's the square root of u. Do y'all see that it's the square root of blah?
Yeah.
So I would say 1/2 blah to the negative 1/2, but then when I went back for the inside, what do I then encounter? A quotient rule. You see how one's a quotient rule on the outside and one's a chain rule on the outside. Okay, right now though you're not worried about it because the only thing inside right now is x. Alright, so I'm going to say my derivative is, here's my announcement y or g prime. I'm going to say low, d high, Like, no kidding, when I'm sitting at my desk by myself and you're nowhere around, and this point in time, I usually work all the homework problems real quickly just to see what problems you'll most likely have. If I'm doing it myself, I've learned the hard way that I better just plan it all out. Are y'all okay with that? Low D high. Alright, now when I take the derivative of this, I'm gonna go 1/2 x to the negative 1/2, and then go back to the inside, but what was the derivative of x? 1, so you see it didn't matter. But that's not really a composite function, it's just square root of x. Had it been square root of 2x, it'd be a different ballgame. Don't forget to go back to the inside. Okay, now low D high. And then I'm guessing you looked at Calc Chatter at the back of the book and went, I did not get the same answer they got. Okay, so now let's calmly, and please listen, if you're like, oh my gosh, you know, why did I sign up for this course? It's 11:20, when is lunch? Please pay close attention. I will make your life so much better. Biggest mistake people make is they go, oh, I like that, negative exponent common denominator factor. But they'll plop that down here. That does not belong down in the bottom, okay? This does not belong down there because it has absolutely nothing to do with this back part. So it shouldn't go under it. Do y'all see what I mean? This is a term, and this is a term, and this over another term. So you've got to stay within the term you're working on at first. All right, so I'm going to say y prime is equal to negative exponent common denominator factor. I'm going to write this as, you'll get used to it, x, can y'all see this okay? X cubed plus 1 over 2 root x. X cubed plus 1 over 2 root x. What did I do here? Right here, I jumped my common denominator down, and what was already sitting there waiting on that negative exponent was the number 2. Do y'all see that? So you just throw it down there in that denominator, but it exists only for the first part. This is minus 3. I'll call that square root of x squared for now, or x squared times the square root of x probably looks a little better. At this point, we may take a couple of different routes. Some of y'all may want to call that x to the 3/2, where you add your exponent. I do that a lot. Over the bottom, that you better not have forgotten about. I cannot tell you how many papers I've graded in the past 900 years that people have just totally forgotten about the bottom of the quotient rule. It will happen to you. Hopefully in homework, that's why I say do your homework, because then you'll catch yourself. But you see how tempting it is? Just go low D high minus high D low, kind of like the product rule. Don't forget over low low. All right, now negative exponent. I've done a lot of talking, but all I did was put that next to the negative 1/2 on the bottom of the thing it was multiplied to. What's your second step? Common denominator. The easiest, fastest way to clear this up is to multiply the top and the bottom by the problem area, which is 2 root x. 2 root x. That's an okay algebra move. I did it to the top and the bottom. Okay? Now I'm going to distribute, and it's going to get a lot clearer. Alright, now that I distribute, when I distribute this, I get x cubed plus 1. What happens to the 2 root x? It cancels. And here you've got to be careful behind the minus sign, but there's no pluses, so I'm not real worried. That becomes 6x cubed. Look at that. It's amazing how it cleans up so often. It's really weird. I just get a cute little polynomial up there. Do y'all see how I got 6x cubed? What's square root of x times square root of x? So I have x here, and that x squared. Over the bottom that you have not forgotten about, I hardly ever multiply out the bottom because of what's my third step is factor. I don't want to multiply something out, just a factor. Alright, so this gives me 1 minus 5x cubed over 2 root x times x cubed plus 1 squared. And later on we'll find the zeros of all of that. By the way, that's a sum of cubes. That can be factored, but it wouldn't cancel with anything, so I'm going to move on. Y'all see how helpful that is? Negative exponent common denominator factor, negative exponent common denominator factor. There's something else, a couple other things on the same here. I was gonna make it, oh, this is big. Exclamation point, exclamation point, exclamation point, star, 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 okay? This is big. I hope people are listening at home, okay? This is big, all right? What's big about this is none of us like that. And when you encounter the problems, which we will a lot, there's always about 4 people, and I never know who they're going to be, that this does not sink into until test day. That's time consuming, and you have to be really careful. But a lot of my questions are going to be write the equation of the tangent line, or what's f prime of 4, right? So please, when you're asked a question like that, just leave it in its purest form and start filling in X right away. Y'all see if I wanted f prime of 1, I'd be slapping that in right there, because it's in its purest form, because I just went low D high minus high D low, 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 low. After that, my mistakes are going to happen. Do y'all see what I mean?
Yeah.
Also, I've wasted time. Am I going to change the derivative at 1 by doing algebra? And you'd be so mad at yourself. You'll wonder why people are turning in their test and you haven't turned yours in yet. Like, how are they doing that? Just because they're just taking the product rule and going, bam, I'm going to fill in 0 right now. I'm not going to clean it up. If you get to fill in numbers, do it when? First step, on your purest form, because it's also a whole lot easier to clean up numbers than it is letters. Okay? I can't make that big enough deal. All right, so now let's go to, I tell you what, I'm going to jump to a problem. Well, looking at the time, I'm good. So it's kind of a small miracle. I'm sure you have lots of other questions, so I'm going to plow through some things that I had started. I'm also going to do the one if you really tried your homework with the graphs in there. I'm going to over it with a couple of y'all. Let's go to let's just, well, I'll tell you what, you ask a number. Anybody have
One of the last 3.
I just don't. Like, if you do 80, it's like this.
Yeah, by the way, I'm going to go to 81 in just a minute. Way back on number 13, you had a function that is x cubed plus 4x. By the way, if they call it f of x, you call it f of x. If they call it g of x, you call it g of x. But later on in a problem, it might mean whichever one you need. And this is times 3x squared plus 2x minus 5. And our instructions on number 13 was f prime of 0. If I did it both ways, and I'm not going to belabor that point with you, you don't need me for that, but I FOILed it out and took the derivative and filled in 0, and I did the product rule and took the derivative and filled in 0. But watch how easy the product rule is here. I don't think I would even FOIL that one out, because it's a little bit more than a 2 times 2. It's up to you. You can. I don't mind. But f prime of x is first times derivative of the second plus the second times derivative of the first, and I didn't take the derivative of the second. Anyway, there may be all sorts of other things I can do to this, like factor and cancel and blah, 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 but you see right now, I'm just going to slap in 0 right here, right now, okay? And it's beautiful, because if I put in 0 here, I don't even have to mess with the front, do I? Okay, so it's a big deal, all right? By the way, you would never, well, I'll get to that later. All right, so I think someone said 81. Let's jump to 81. All right, 81 was, okay, oh good. Okay, I have a slide for that. All right, so this is 81. It's also the kind of thing that, you know, if you kind of got it and you felt you tried your homework, you wanted to clarify, that's fine. But if you didn't have any idea, which some people contacted me about this one, you should ask. These kind of things will be on the AP exam. They will find out if you know your stuff, okay? So this is graphically. First of all, let's find, here's P of x. So let's find P prime of x. P prime of x is first times derivative of the second plus the second times derivative of the first. I won't be that lazy. I need the x in there. First times derivative of the second plus the second times derivative of the first. All right, so P prime of 1 is equal to F of 1 times G prime of 1 plus G of 1 times F prime of 1. This would be a time on the board I should have written the word literal, okay? Be very literal. F of 1 you can find like you did in Algebra 2. F of 1 is 6. Are y'all okay with that? What in the world does G prime of 1 mean? The slope of the tangent line at 1, okay? So why is this a fair question? You don't even have to estimate. Here's G of 1, but G prime of 1 is talking about the slope of the tangent line at 1, and they put it on a grid like this, girls. You're going to see things on a grid, and that means you're going to be counting yourself, okay? You're not going to have to estimate. We're all going to get the same answer. So did y'all see that was down 1 over 2 all during that time? The slope is negative 1/2 at that moment. So the slope is negative 1/2. And then G of 1 I think was 4. And what is F prime of 1? Isn't it up 1 over 1 during this time? And so I get negative 3 plus 4 or 1. Okay? And always make sure you've given a notation of what it is that you're doing. All right, so let's do, are y'all okay with that? Can I erase it and do B?
Yeah, sure.
All right, so let's do 81B. All right, so Q is a quotient. So I'm going to say Q prime of X is low D high. Quantity squared like that, okay? So now I'm going to do the same thing. I'm going to find, this is a 4, so I'm going to have, I'm kind of in a hurry, so I'm just going to throw some ugly 4s in here. You're not allowed to do that, but I am. All right, I haven't worked this one, so I can't even see. G of 4 is 3. G of 4 is 3. F prime of 4. So this is F of 4. And F prime of 4, let's take us down 1 over 1. It's slope minus F of 4 is 7. And G prime of 4 is 0. Do y'all see your slope would be 0 there? It's not changing at all. Derivatives are all about rate of change. It's not changing, so the slope is 0. Over the bottom squared, which G of 4 is 3 squared, so I believe you're going to get 9. So it looks like you get negative 1/3 for my ugly writing, okay? And I actually haven't done 82 in a few years. Was it okay? P prime of 4?
I don't think we have to do it.
Okay, so I was just saying, so you would do something similar. Okay, let me see if there's, I definitely want to do at least one more problem. Let's look at 24. Nine, 29. Did you do 29?
Yeah.
I just can't read my own writing. Okay, I got to get to this slide. It's so cute. All right, so y is equal to 3x minus 1 over root x. I would not do this problem this way, but I want to do it to go over my skills, and I'll tell you how I really would have done it. Let me tell you what I really would do. I would simplify this before I start. If I have one item as a denominator, I'm actually going to start writing it like this. And do the power rule. I'm just going to start putting the denominator with everything. Did everybody see how I simplified that? I don't want to do the quotient rule if I don't have to, okay? So I may talk about that one later. But if I did do the quotient rule, then I'm going to say low D high minus high D low over low low. All right? And normally I would have written it all out and gone back to it. Don't forget in your homework for Wednesday, you might have something inside to go back to, a chain rule. All right, now negative exponent So I have 3 square root of x minus 3x minus 1 over 2 root x all over x. This just goes right underneath what it's multiplied to. And there was a 2 already sitting down there. And that's a 3 in the front, a really ugly 3. Then I would do common denominator. Sorry, the 2 big examples I've done today, I think, have a 2 root x in them. And then you would continue on and get the answer in the back. Okay, so right now, you haven't encountered many that factoring is a really big deal in. But you will. Right now, it just sort of ends at like a statement that you can't even factor or do anything with, but that third step's going to be big. Don't start multiplying too much out, because chances are you have to factor it later when these problems get bigger. Are there any other last minute questions before we go? All right. I finished 2 minutes early.
Wow.
And I'll post the homework in a few minutes, okay?